Can you all hear me okay? Awesome. Well, thank you all for joining. Good morning. Hopefully everybody had a good night of sleep and is feeling recharged and refreshed for today. Hopefully not too much tequila last night. To introduce myself, my name is Kyle Winters. I am a technical advocate with the Learning and Certifications team here at Cisco. I've performed various different roles across Cisco and with various different startups as well, ranging from consulting to developer relations, worked with many different companies, Fortune 500 companies, to help secure their networks and their infrastructure. And today I want to talk to you about an exciting technology that might be relatively new to a lot of you, and that is eBPF. We're going to take a bit of a focus on network security engineers and how they can leverage eBPF. Just to give you a little bit of an agenda, we'll start by covering what is eBPF. We'll talk and then essentially go into some examples. I wanted this to be a very live, interactive demo where we can see eBPF in action. So we'll perform various actions like tracing system calls with eBPF, as well as doing packet filtering with eBPF as well. We'll conclude by talking about why we're discussing eBPF today and how that relates to Cisco Hypershield, which will be coming out in the near future. So to begin, what is eBPF? And to start, before we even discuss what eBPF is, let's discuss what the kernel space is. So most of us are familiar with operating with computers and systems in the user space. And that includes things like web browsers, text editors, all the code that you write, the Linux terminals that you're interacting with, where you're running the code. That's all in the user space. There's also the physical hardware as well, too. And that includes things like the network cards, memory, storage, the disk, the keyboards. All of that stuff is considered in the physical space. Now, applications in the user space need to be able to talk to the physical components that exist on the server. However, it's rather complex for those applications to know how to directly discuss or to talk to all the different types of network cards, disks, etc. that exist. There's a lot of different vendors that create physical hardware, and it's a bit complex for the user space to know how to communicate with those different components effectively. Applications ultimately just want to be able to perform XYZ function, and that can be done a lot of different ways in the physical space. And that's where the kernel space comes in. It sits in between the user space and the physical hardware, and it allows for a normalized way for the user space to communicate with the physical space. So it sits in that layer there. It's handling things like system calls, device modules and drivers, and it allows for an easy, normalized way to communicate from that user space to the physical hardware. But what if you need to make changes and extend the capabilities of that kernel space to do new and unique things? Well, that's where eBPF comes in. It originated from Berkeley Packet Filter technology. Originally, the acronym stood for Extended Berkeley Packet Filter, although that acronym has been dropped, and it's just now called eBPF because it can do so much more than just packet filtering. It's a safe and efficient way to extend the functionality of the kernel and add new additional capabilities into it without requiring any changes to the kernel code. If you ever try to change kernel code, it's a very complex, difficult, and highly not recommended process to do. And that's where eBPF comes in. You can deploy these essentially Linux kernel modules to extend and modify the function of it. It's easy to use. There's a lot of code that's written. eBPF itself is written, the code is in C. But there's a lot of wrapper libraries that we're going to share and use today in things like Python and Go as well. But there's a lot of performance advantages to it. You can deploy these modules as well dynamically without having to restart and reboot the system. And you're not changing any of the actual source code in the kernel as well. It has built-in security. It's got a lot of tooling options, and I'll share some of those with you here shortly. But just to give you a little bit of understanding of the basic concepts of eBPF, Let's start with eBPF hooks. So on its own, eBPF allows for safe and efficient execution of that custom code in the kernel. And it starts essentially by loading the small programs into the kernel. Like I mentioned, these are written in C programming language, but it's a very restrictive version of the C programming language. And these programs can attach to various different hooks inside of the kernel and run in when specific events occur. So an event might occur on the system, and that hook will trigger a specific eBPF program to run. Now, the run that occurs, those are the helper calls. So inside of an eBPF program, you might have different types of helper functions that allow you to perform specific eBPF capabilities. And that can range from things like searching for specific content, updating things, generating pseudo-random numbers, collecting and flagging metadata, doing things as well like binding to sockets, retrieving cookies, redirecting packets. There's a lot of capabilities that it can be doing with those helper calls. We also have the concept of eBPF maps. And consider this like a hash map. It's a key value pairing that is stored in memory on the kernel. And this allows you to store data that can be then called later. So you can have an eBPF helper function write data to an eBPF map, which is essentially a hash map, and be able to retrieve that data later or reference it. So we're going to actually be using eBPF maps in one of our demos here as well. So you guys will be able to see that hands-on a little bit too. Now, when it comes to network security, there's a lot of different use cases that can be applied for eBPF. You can do advanced packet filtering and processing. So you can inspect, filter, manipulate packets at various different stages of its journey through the networking stack. You can do things like DDoS mitigation as well too. You can do intrusion detection and prevention and be able to detect suspicious activities such as unauthorized access attempts. There's runtime security enforcement built into it as well. You can detect things like data exfiltration, even application sandboxing. This can all be done through eBPF. There's actually a ton of use cases. And if we go back a couple slides here, you'll see it's not just related to security. There's a lot of networking and observability use cases tied to this as well. So a lot that can be done with eBPF. For today's demos, I'm going to be using a library called BPF Compiler Collection, also known as BCC. This is a great toolkit for creating efficient kernel tracing and manipulation programs. It's highly used in Linux. It has a Python and a Lua wrapper that are available for you to use, and we're actually going to use the Python SDK for it today. But it's a great one, has a lot of good applications for things like performance analysis, network traffic control as well. But I do want to make mention of another great tool that's available. We're not going to use it today, but it's a very popular one called Cilium. It's very focused on network and security for containers and microservices. It's utilizing eBPF to perform networking, load balancing, have security features. A lot of these modules are pre-built, so you can essentially download and run these eBPF Linux kernel modules just through Cilium and save yourself some time and effort there. But let's go ahead and start by tracing system calls with eBPF. I'm going to talk about these different concepts, and then at the end, I'm going to do a demo of all of this as well too. But we're going to take you through some of the code here. And as you can see, this is actually a Python package that I built that's related to eBPF. And what this library does, and I'll take you through it a little bit here. You can see we're importing BCC. That's the library that I was telling you about earlier. And right here is actually our BPF program. Now you see it's a string, but this is actually C code that is stored in this string here. So what this is doing is it's reading in the system call. And if the system call is to create a new directory, we're going to print that out to standard out. This is a way that you can essentially trace system calls. You can extend this further to be able to do things like logging and monitoring of activity on your Linux systems. And then, by the way, this is all available on Cisco U as a free tutorial as well. So you can download this source code and be able to run through these exercises yourself. So that's the actual eBPF program, that C code there. Here's where we're actually loading and running that. So you can see that line 11 is where we're initiating the BPF object, and the parameter that we're passing is that source code above, that C source code. And lastly, we just have an event loop here that's going to print the messages anytime there's an update to a directory that is created for eBPF. The directory that's created, eBPF is going to recognize that through the calls that come in and write that out to standard out. Now, I'll give you a demo of this in a little bit, but I want to talk next about a little bit more advanced capability, and that is packet filtering with eBPF. Get a sip of water really quick. So networking might be more of an interest to you all, and being able to filter out packets leveraging eBPF is a great way to kind of test out and play with eBPF from a networking perspective. So I have a demo environment here. I've got two Linux servers. They're both running Ubuntu. One is 192.168.9.130. That's going to be our source. And our target is going to be 192.168.9.131. And that's the target one is the one that we're going to run our eBPF program on. So we're going to try sending pings and SSH connections from the source to the target. And at first it's going to work. But when we run the eBPF program, you're going to notice that those packets are going to get dropped and that connection's not going to be able to work. So the way that we do this is by first reading in the packets that are coming in and taking a look at the IP header and the TCP UDP header. We're then going to extract that data, specifically the source and destination IP addresses, the source and destination ports, as well as the protocol that is used. And then we're going to put that into an eBPF map. So we're going to store this in memory, have the information on this, and when we see packets come in, we're going to perform a lookup. It's going to extract that packet, the necessary pieces of data there, look it up, and if any of that matches what we have in this hash map, this eBPF map, we're going to discard those packets. So there'll be no communication available between those two devices. Now, this is just a snippet of the code. We do have a tutorial launching in the next week or so that is going to cover this. It's going to be called Advanced Packet Filtering with eBPF, and it will include hands-on. It'll have these sample code here that you can play with, as well as detailed instructions that cover eBPF in a little bit more detail. But to start, we import these libraries here into our C program, and that includes things not just for BPF, but also for IP, TCP, and ICMP as well too. We then create the data structure that we're going to use for our eBPF map. And again, that maps over to the things that we discussed earlier, the source and destination IPs, the ports, as well as the protocols. And those are stored as integers inside of this data structure. With that data structure, we then create that eBPF hash map that you see here that we're going to then write that data into for the things that we want to discard packets for. And then that actual filtering functionality is done here, essentially recognizing when that packet comes in, that matches that, it does that lookup, and it goes ahead and discards those files. Now, we have a Python script that is going to run a lot of this. And like I said, this is going to be available to you all on Cisco U as a free tutorial. But if you go ahead and run this, there's a couple of pieces of information that we need to configure in here first. The first one being the interface name. So we need to know which interface we're reading the packets in from. So we need to go ahead and modify that interface name to match what is the interface on our particular server. We also need to populate the IP addresses that we want to discard the packets from. So depending on your lab environment, it's likely going to be different IP addresses and a different interface name than what is listed here. So I just want to point that out so that way you can go in and be able to modify those and you can get the script working properly. Without further ado, though, I'm going to go ahead and jump into the live demo here. Give me a second while I pivot over. Let's do this. All right. You can all see this okay here? Good. So let's just go ahead and start by validating whether or not we have eBPF running and configured on this particular Ubuntu host. So you can just run this command here, more/boot config. You give it that particular uname-r function, it'll auto-populate that in there for you, and you grep for the words config_bpf. And if you see this here, config bpf equals y, that means you have eBPF enabled on this particular device. So let's go ahead and start first by checking if we can run the system calls. So I'm going to go ahead and open up a Python package that I have called eBPF system calls. And you can see this is our Python package here. There's the BPF source code that is written in C. And all of the functionality that I mentioned before is all here. So let's just go ahead and quit out of this. And let's go ahead and run this program. So we're going to do sudo python 3 eBPF system calls. Enter my password. So this is running right now. And you're going to see if I create a new directory here called test, it recognizes that that new directory was created and it writes that out to standard out. So you can extend this capability a bit further to do logging of all different types of system calls. And that's a great way just to do essentially observability monitoring of your Linux systems and be able to track if anything is happening on those systems that is not expected. If all of a sudden strange new directories are being created that you're not expected, that could be a potential malicious actor that you want to know about. So being able to trace this, these system calls and recognize them and log them is one of the things that you can do with eBPF. Now, let's get into a little bit more advanced use case. And let's just actually take a look really quick at some of the things that you can do with the built-in Linux functions. So if you come in and let's just say sudo, actually, let's just do this really quick. ls user sbin bpf cc. You're going to see there's a ton of different pre-built functions that are available. These are all leveraging eBPF to perform different things. And you can call these functions directly here as well, too. So there's one that I'm going to show you really quick. Let's just run this one, sudo user sbin tcp connect bpfcc. So what this is going to do is going to read for any TCP connection that occurs on this particular device, and it's going to write it out here. So in this other terminal window, it's SSH to the same host. I'm going to go ahead and just do a wget to google.com, and you can see that gets tracked right there as well. So because I'm on a closed network, the connection fails, but you can see that those communications are being tracked there too. So let's go ahead and pivot now and do some packet filtering. So I'm just going to clear this out. And I'm going to go to a different host here. So I have Ubuntu 1 on the left. That's the .130 host. And on the right is Ubuntu 2. That's the 131 host. And we can just check and validate our interfaces and our IP addresses here with IP adder. So you can see there it is, 130 on the left, 131 on the right. And there's our interface name right there, ENS 160. So let's go ahead and open up our packet filtering program, and that is this eBPF packet filter.py. And like I pointed out earlier, there's a lot of different components to it that are already here. This is all of the C code that's written here, performing all of that filtering functionality. You've got the Python program here that is initiating that BPF object and passing the program, that's the C code, as a parameter. We've gone ahead already as well too and put the name of the interface that matches what we have on this particular server here, ENS 160. And we have the IP address of the source here, 192.168.9.130, which matches over here on the left as well too. So we have this configured and ready to go. Quit out here. And let's just clean this up a little bit. So to begin, I'm going to go ahead and just send some pings from the source over to the destination. And you'll see that this is going to work no problem. Looks like normal pings, right? We're getting responses back. Everything seems to be working functionally. We can go ahead and try an SSH as well too. SSH tile at 192.168.9.131. And you can see we're successfully able to SSH now into that host. But what happens if we run this eBPF program? So let's go ahead and give it a shot. Python 3, eBPF, packet filter.py. You can see this is running. It's monitoring the traffic now. And if I come back to this host over here and I try pinging it, 192.168.9.131, you'll see we're not getting any responses back from that server. Those pings are no longer going through. Those packets are being discarded by the kernel and are no longer essentially being processed by this server on the right here. We can go ahead and try with a TCP connection as well. You can see, by the way, there 16 packets transmitted, 0 received, 100% packet loss. So we know that it's filtering those packets out correctly. And if we try that SSH function again as well too, you're going to see that it's not going to connect, it's going to time out. If we want, we can go ahead and just kill this program here, run this again, and it's all back to working again. So this is just an example of some of the things that you can do with eBPF. Hopefully this sparks your interest a little bit and gets you interested in some of the more capabilities that we have available when it comes to eBPF. Let me go ahead and share my slides again here. Give me 1 second. Alrighty. So why are we talking about eBPF to begin with? Why is this relevant to the Cisco sphere and the Cisco world? Well, we recently acquired a company called Isovalent, who's heavily involved in the eBPF space. Some of their engineers were some of the original founders of eBPF technology as well. And you may have heard the term Hypershield recently. It's been a lot of the talk around the Cisco town. This is a new technology that's going to be coming out. It's going to be a scalable, hyper-distributed, AI-driven data center technology, and it's going to be essentially built on top of eBPF. So all the capabilities that Hypershield is going to be able to perform are going to be leveraging eBPF. So that's a big part of it. It's going to allow you to leverage generative AI to assist, augment, and automate your data center infrastructure, leveraging eBPF under the hood to perform a lot of these functions. So you're going to hear more about eBPF in the next year as it becomes more available. But for the time being, getting an understanding of the core concepts around eBPF is going to help you be more prepared for when this technology comes out. So I appreciate this time that I shared with you all today. Hopefully this was valuable and you learned a thing or two about eBPF. If you are interested in learning more, though, we have a lot of resources available. You can start at ebpf.io. That's a great resource on there as well, too. There's a lot of information that's available. We do have eBPF tutorials available on Cisco U, too. These are free for anybody. So you can sign up, have a free account, and be able to do these eBPF tutorials at any time that you want. There's also interactive labs on isovalent.com that you can access, and there's a lot more educational information that's available to you there as well. If you're not familiar with Cisco U, by the way, it's a great learning platform. It's addressing skills gaps that exist in our industry and teaching different core concepts across networking, security, collaboration, data center, etc. There's a ton of free tutorials available on there, as well as premium content that will steer you towards things like certifications. So you can take a whole certification course that has interactive labs available on Cisco U, that's u.cisco.com, and be able to skill up and reskill more effectively as well too. So if you're interested in learning more about Cisco U, you can speak to my colleague Joe over here, and he'll give you a nice demo of Cisco U. But while you're here as well too, feel free to check out some of our other sessions that we have here across the Cisco U Theater and in other places. You can book time one-on-one with an engineer, participate in Capture the Flag, hang out here and get more free lunch boxes and have some drinks with us later maybe. But hopefully this was an informational and valuable session for you all. If you did appreciate this, feel free to fill out the survey. You can access it through the app or by scanning that QR code there. Your feedback is always appreciated. Otherwise, thank you all so much for the time today. Oh, I do have one more thing. We have these beautiful Cisco U Stanley water bottles here, and one of you may not realize that you have won this already. One of you has under your seat this little thing, this little heart. And if you have this little heart under your seat, you get this free Stanley water bottle. So let's see who the lucky winner is. There it is. Congratulations. Here you go. We'll be giving more giveaways later today as well, too. So if you come check out some more sessions, you might have a chance to win a water bottle or even this pickleball set. I just highly recommend that you